Hello everyone, welcome to an algebra lesson. We are starting Unit 6 today, so this is 6.1 Part 1. There will be a Part 2 in the next lesson. This is called Operations on Functions. And before I get too far into it, let you know I'm recording this from home, and my dog just climbed up onto the chair with me. So if you hear any sounds in the background, probably my dog sitting here, I don't know. Anyway, operations on functions. So we're going to be looking today at the four basic operations, which are adding, subtracting, multiplying, dividing. When adding functions, you're essentially just combining like terms. We've done plenty of this so far this year. Subtraction involves distributing a negative sign and then combining like terms, just like adding. Multiplying could be the distributive property or FOIL. I think on this worksheet it's all FOIL. For dividing, you just use a fraction bar to represent division, and then you state something called domain restrictions. And we'll get into this a little bit. With a function, domain are the x values. It's the values that generally get plugged into a function or substituted into a function. Domain restrictions are values that cannot be substituted into a function. There's certain numbers you can't plug into a function, because what happens is when you try, you end up getting 0 in the denominator. Remember, this goes back to dividing, and we'll be using the fraction bar for dividing. So basically, each one of these answers works out to be a fraction. And if there's ever anything that puts a 0 in the bottom of a fraction, this is called undefined. And you just cannot have that in math. So that's like probably the biggest detail of today's lesson. All this other stuff is going to be pretty simple for you, I imagine. But this is one thing I'll have to explain more in depth when we get down there. So the directions simply say perform the indicated operation. I'm going to do the evens, going to ask you to do the odds. Remember function notation. Function notation is usually like f of x. F stands for function. X is the variable, so you might have like 2x plus 5. F of x equals 2x plus 5 is the same thing as y equals 2x plus 5. F of x and y are the same thing. Now, every function doesn't have to be f of x, so you can have h of x or g of x, or I don't know, maybe there's some other things. And you don't even have to use x as your variable. As you can see here, there's t. This problem over here has n. So we're going to have to get used to this notation and these variables. But it's still, you're going to find it fairly simple, I think. So number 2 says find h plus g of t. This is basically asking us to take the function h of t and add it to the function g of t. So what's written right here means this. It literally means add these two functions together. And some of this work you can probably do in your head. I'm going to write out all the steps because that's, how I do things. But to add these together, basically I'm going to bring down the first one and add it to the second one. And when you add, all you have to do is look for like terms. So we get t cubed minus 1. In fact, in this step here, technically these parentheses don't even really matter with addition. So it's t cubed minus 1 plus 4t minus 2. And like terms are essentially just the minus 1 and the minus 2. So t cubed is not going to change, plus 4t, that's not going to change. Minus 1 minus 2 is minus 3. And there it is. We've just added those two functions together. Let me scroll down and check number 2 to make sure. And there it is right there, exactly right. All right, let's do number 4. 4 is just repetitious. It's another addition problem. So g plus h means g of x plus h of x. So I need to take this function, negative 3x cubed minus 1, and add it to this function, which is 3x minus 4. Now I'm in the habit of putting these parentheses down because in most other problems, the parentheses actually matter. Addition-wise, they kind of don't. So if you skipped that step on this problem and just wrote it this way, that would be fine. But that's not the answer because we do have like terms. Minus 1 and minus 4 combined to get minus 5. So we're going to have negative 3x cubed plus 3x minus 5, and that should be our answer for number 4. Let's see. Oh, too far. And there it is. Okay, next, number 6. Now this is a subtraction problem, f minus g of x. So this means you're going to take f of x minus g of x. So this is one form of notation that basically means the same thing as that. So it means take the first function, 3x plus 5, minus the second function, which I kind of covered up there, the second function, x cubed plus x. Now here, when we go to rewrite this, we get 3x plus 5, but you have to distribute this negative sign and apply it to everything in those parentheses. So you get negative x cubed, negative x, right? When you distribute the negative to this positive, it turns negative again. And so now when it comes to like terms, the 3x and the negative x are like terms. So if I want to simplify this, I'm going to put negative x cubed first. So that's this one. It's the highest power. I put it first. And then 3x minus x is positive 2x. And then bring down that plus 5. And that should be the answer. Negative x cubed plus 2x plus 5. Let's look at number 8. Now this does look like a long assignment. There are 24 problems. So you're going to be doing 12 when you do the odds. My answer key is all spread out instead of being consolidated on one page. So that's why this assignment looks really long, but it's not that bad. Okay, number 8. So this is g of x minus h of x. So that's the first one, 3x plus 5, minus the second one, x squared plus 2x. What am I going to do? I'm going to rewrite this, and I'm going to distribute the negative and rewrite that. Now I look for like terms, so 3x minus 2x, oops, that's extra dark, isn't it? That was weird. 3x minus 2x is 1x. So, okay, let me put the minus x squared first. That's the highest power. And then 3x minus 2x is positive 1x. And then bring down the plus 5. And that should be that. Oops. Check number 8. And that looks about right. So, moving right along here, hopefully you're finding these fairly simple and straightforward. Number 10, f times g of x means we're going to do f of x times g of x. So that's going to be the first function, 3x minus 5, multiplied by the second function, which is x cubed plus x. When you multiply in a situation like this, you do have to do the FOIL method. So I'm going to multiply first. 3x times x to the third is 3x to the fourth. Remember, there's like a first power there, and you add the powers. 1 plus 3 gives us that 4. So that's first. Outside 3x times plus x, that's going to be plus 3x squared, because that has like its own first power. 1 plus 1 is 2. For the inside, and I'm going to do things a little different here. I'm going to multiply here. Negative 5 times x cubed is negative 5x cubed. And then last, negative 5 times plus x is negative 5x. And I don't see any like terms to combine. This is pretty much the right final answer, except that it's good to be in the habit of writing your answers in descending order. Descending order referring to the powers. So highest power, second highest power, third highest power, and then end with the lowest power, which of course is a 1. So this ought to be what the answer looks like. Let me scroll down to number 10 and check. And there it is. So number 12 is just kind of repetitive version of number 10. F of x times g of x. First function times second function. And FOIL it together. So first, x squared times negative 2x is going to be negative 2x cubed. Outside, x squared times negative 2 is negative 2x squared. Inside, negative 1 times negative 2x is positive 2x, right? Negative 1 times negative 2 is positive 2. And then last, negative 1 times negative 2 is positive 2. There are no like terms, and the powers look like they're in the proper order, so that should be the answer to number 12. No extra fancy steps or anything, I think, right? And there it is. Brilliant. Wonderful. Doing just great. Okay, number 14. Excuse me. So this here is divide. This says g of x divided by f of x. So that means we need to put this function, the first one, x squared plus 2, over the second function, this one, 2x plus 4. And there's no way to divide that. I mean, we could do the long division or synthetic division, but you don't have to in these problems like we did in the last unit. You just leave your answer like this. Now let me go down and check number 14. If eventually I can check, there it is. And there's this part of the answer, but then there's also that. So this is what we called the domain restriction. So let me explain how to figure that out. Where does this domain restriction come from? So here's what you do. So we put this on top, this on bottom, or if you prefer top and bottom, you can say numerator, denominator, whatever. But set the denominator equal to 0 and solve it. Or actually, technically, we're setting the denominator not equal to 0 and solving it. Because like I said before, denominators of fractions can never equal 0. That's called undefined. You cannot have that in math. So you take the denominator, which was 2x plus 4, and set it, let's say, not equal to 0, and then work it out. So minus 4 on each side. You get 2x is not equal to negative 4. Divide by 2. X does not equal negative 4 divided by negative 2 is negative 2. So you just write comma. X cannot equal negative 2. Why not? Again, because if you were to plug that negative 2 in, you get negative 4 plus 4, which is 0, and the denominator in a fraction can never equal 0. Say it with me. The denominator of a fraction can never equal 0. So that is the full answer. All right, let me do number 16. Be kind of repetitive. So this is f of x over g of x. So draw a fraction bar. Put the first function on top, the second function on bottom, and then set the bottom function not equal to 0. It seems weird, but it's how you do it. Add 1 to both sides. 2x does not equal 1. Divide by 2. X does not equal a half. So you put comma, x does not equal a half. That should be the full answer to number 16. Let's check, and there it is. Okay, so that is kind of a new little twist, a thing you've probably never contemplated or saw before. The rest of this should be things you've seen before. Combining, oh, calm down, dog. Combining like terms through adding, subtracting, distributing a negative sign, the FOIL method, all of that's real familiar stuff, or at least should be for you. Now the rest of this worksheet looks like this. It's very, very similar, except we have a number here instead of a variable. Now what does that mean? F plus h of negative 10. Well, this means, I'm sorry, g plus h of negative 10. That means g of negative 10 plus h of negative 10. That means you need to plug in a 10 to each one of these. So we're actually dealing with numbers. So this first one, x squared plus 5 becomes negative 10 squared plus 5. If you work that out, you get 100, right? Negative 10 squared, negative times negative is positive. 10 times 10 is 100, plus 5 is 105. And then you plug negative 10 into the second one. Negative 10 minus 1 is negative 11. So to add these together, it's going to be 105 plus negative 11. Take this answer and that answer. Well, negative 5 plus 111, plus negative 11 is what, 94. Use a calculator if you need to. Number 18 should be 94. Let me double check, and there it is. So it's the same as what we did before. There's just numbers involved, and not quite as many problems either. So g minus f of negative 6. G of negative 6 minus f of negative 6. Plug negative 6 in here. That's negative 6 squared plus 4 times negative 6. And work that out. Negative 6 squared is 36. 4 times negative 6 is minus 24. 36 minus 24 is negative 12. Plug negative 6 into the second one. 3 times negative 6 minus 4. 3 times negative 6 is negative 18 minus 4. That's negative 22. So when we do g of negative 6 minus f of negative 6, we're going to take that first answer, negative 12, minus the second answer, negative 22. When you minus a negative, it turns to plus. Negative 12 plus 22, I believe, is positive 10. Check number 20. Where am I? Uh-oh. Uh-oh. 34. What did I do? I think I know what I did. Duh. 36 minus 24 is not negative 12. Duh. Positive 12. I'm a cotton-headed ninny-muggins. That's a positive 12. That's a positive 12. What's 12 plus 22? 34. That's where that answer comes from. All right. Number 22. H times g, right, that's times, h times g of negative 3. So h of negative 3 times g of negative 3. So I have to plug a negative 3 into this function. Now this function already has a negative, so it's going to be negative 3 plus 1. The double negative is positive. 3 plus 1 is 4. So there's that first answer. Plug a negative 3 into this one. Negative 3 squared minus 5. Notice I'm using parentheses. I've done that on every problem. Because when you square a negative, it turns positive. That 2 applies to that negative. A negative times a negative equals a positive. So negative 3 squared, hold on. Negative 3 squared is positive 9 minus 5. 9 minus 5 is 4. So h times g is this answer times this answer. 4 times 4. It should give you 16 as an answer. Oh, there we go. Whew. I looked at that 34 and like, I can't be wrong again. No. By the way, a lot of what I'm doing here, you are free to do on a calculator if you need to. So all of this work that I'm writing out here, if you type that into a calculator, so be it. As long as you're getting the right answer, it's all good. Number 24, g divided by h of negative 9. So I got to do g of negative 9 divided by h of negative 9. Now here we don't have to worry about the restricted value. The restricted domain value only happens when there's a variable in the bottom. We're going to have numbers here. It's not even going to be an issue. So watch. Plug in negative 9. Negative 9 squared minus 5 times negative 9. That's negative 9 squared is positive 81. Negative 5 times negative 9 is positive 45. Eek. That's 126. So the top number works out to be 126. Let's do the bottom. That's negative 2 times negative 9 plus 1. Negative 2 times negative 9 is 38. But negative times is 38 plus 1 is 39. Ooh, I don't like the looks of this. 126 over 39. Let me grab a calculator. Oh, look. Okay, what you see on the screen right now is called trigonometry. You might get to do that sometime this year. 126 divided by 39, a decimal. So either I did it wrong, or the answer is supposed to be a decimal or a fraction. Let me check number 24. Oh, 126 over 19. 19? I don't have 19. I have 39. All right, what did I do? What did I do? Oh, that was stupid. Look. I'm supposed to plug in a negative 9 right here. 2 times negative 9. I plugged in a negative 19. What did I just make that up off the top of my head? That's not supposed to be a 19. That's supposed to be a 9. Duh. 2 times 9 is 18. And 18 plus 1 is 19? Well, maybe I should use a calculator, for crying out loud. Okay, so now that that's corrected, that shouldn't be a 39. It should be a 19. The point is, you don't have to do like we did in the other division problems. You can't set the bottom equal to 0 and solve it, because 19 is a number, not a variable. So that's just it. 126 over 19 is the answer, and we're good. And that one eventually did check out as well, so I like a check mark by each answer. Okay, that's it. That's the whole lesson. Please do the odds the same way I did the evens, only try not to make mistakes like I did. And have a great day, and let me know if you have any trouble. I will try to help you out.